welcome to my presentation about hypervisors. My team is working on the OKL4, or working with the OKL4 GUI, so I figured it'd be a good idea to actually myself learn a little bit more about hypervisors as well as maybe teach someone else about hypervisors. So here we go. So today we're going to be covering what a hypervisor is, the history of hypervisors, and why they're important for virtualization. So, what is a hypervisor? So, before the introduction of hypervisors, physical computers could only run one single operating system at a time, which was very stable for the computer itself, but the resources of the computer were massively wasted by the operating system, as it wasn't always using all of the computer's abilities. And hypervisor was, I wouldn't say created specifically for that issue, but it eventually turned into um, that. So, and we'll go over that during the history portion. So, also known as a virtual machine monitor, or VMM, a hypervisor is a piece of software that allows multiple operating systems to run sort of concurrently by sharing the host computers, or all of the host computers' resources. And the hypervisor manages to do this by giving each operating system, or each virtual machine, their own share of the single host resources. So there are two types of VMs. There's type 1, which is called the bare metal hypervisor. It takes control of the BIOS and runs directly on the hardware. And then there's type 2, which just acts as another application and uses that same application's processes to run the separate hosts' processes. There are a lot of different pros and cons to each. Like, for example, a type 1 hypervisor like a Hyper-V can only run on a Windows host system, while a type 2 hypervisor can be run on any host system, but it's pretty inefficient to run one, because when you have multiple VMs running, it can get pretty wonky and start to get some pretty bad system issues, and everything slows down and all that good stuff. So the history of the hypervisor is that originally it was created in the 1960s by IBM, and the original product was used for building time-sharing systems, testing new operating system ideas, or exploring new hardware concepts. And it was originally used as sort of a version control system so that developers could make changes without risking the deployed product. And then later in the 2000s, the system was developed into the first batch of hypervisors and used by Linux, and many realized the abilities of it, and like improved security. It was super cost efficient, because instead of having to buy 10 servers all using only 10% of their power at a single time, they could just use one, spool up a few VMs on it, and now it's using all of that server. And and yeah, and eventually, though, CPU manufacturer companies started adding hardware virtualization directly to their products. So why is it important? First of all, running multiple hosts on one machine, that I went over a little bit earlier, but it made it super cost effective to run a single host, or run multiple hosts on one single machines. It made it very cost effective, which also goes into the last point there. And then speed. Hypervisors allow for instantaneous creation of new systems. So if one system goes down for whatever reason, another host, an exact copy usually of that host, can be booted up almost immediately. And this is useful for security, because if one system is experience a malicious attack, they can simply turn that system off, configure it to take the place of or spin up a new one configured to take the place of the old one, and all of a sudden the attack's done and over with. The second thing is efficiency. Like I said before, a single operating system isn't using the computer's full power, uh, which for a normal desktop computer isn't that much of an issue. But if you have a single server rack worth hundreds of thousands of dollars and it's incredibly powerful, having a single operating system would waste that server's potential. So hypervisor is able to fully utilize everything that server can deliver. So, and then there's flexibility. Hypervisors allow for different operating systems to be run on the host computer despite incompatibility between each operating systems. Although in the case of a Type 1 hypervisor like Hyper-V, can only be run on a Windows system. When you spool up VMs, those VMs can be different operating systems like, maybe different distros of Linux, like Red Hat and Ubuntu, or, whatever operating system you want to run concurrently at a time. So, and then the last thing is portability. So, hypervisors, again, allow for operating systems to run independently of not only each other but the host system. And because of that, it allows for portability, and different workloads can be allocated, such as storage, memory, networking, and processing to multiple systems. So you could have, 30 VMs running on a single server, and if one of those VMs is having an issue running thing, it can delegate those processes to all the other ones. And it can also do this over multiple servers. So you could have, one server rack running 30 systems, another server rack running 30 systems, and they can share resources pretty seamlessly. So, in conclusion, starting as a simple way to manage code edits for developers, hypervisors revolutionized big data. Again, for allowing for instantaneous creation of new systems, cost-effective and secure ways of managing data by running multiple systems independently and using all of the host resources. Hypervisors are regarded as the invention that single-handedly is responsible for today's internet. So, and then there are all my sources. And thank you for coming to my presentation.